Okay, let's work on solving this problem. We need to sketch the graph of the function y equals f of x that satisfies all of those properties simultaneously. So what does it mean? It means that we're gonna solve this puzzle. Usually it's easy to start with the items that talk about the first and second derivative and work out the shape of the graph and then try to satisfy the rest of the conditions. Okay, as I mentioned, we're going to start by trying to satisfy the description of the first derivative. So see that in the description we have -5, -3, +1, +3 as the key points, so put them on the number line. And we said that the first derivative is positive between -5 and -3, and between +1 and +3. And also we're told that the first derivative is negative to the left of -5, between -3 and 1, and to the right of 3. And where the first derivative is negative, the function itself must be decreasing. And where the first derivative is positive, the function itself must be increasing. Now, moving on to the requirements for the second derivative, we see that the numbers that second derivative uses are -2, 3, and -5 and -2. So I'll try to align this number line with the number line for the first derivative. And we're told that second derivative is positive on this interval and on that interval. And second derivative is negative to the left of -5 and between -5 and -2. So we have function being concave down on the left two intervals and the function being concave up on the right two intervals. So now we can try to combine all those requirements. So I bring down all the key points. And we see that on the extreme left interval the function should be decreasing and concave down. That's the shape of the function. Between -5 and -3 the function should be increasing and concave down. So that's the shape of increasing and concave down. Then between -3 and -2 function should be decreasing and concave down. That's how it goes. Between -2 and 1 function should be decreasing and concave up. That's the way. Then between 1 and 3 it should be increasing and concave up. That's the shape. And to the right of 3 the function should be decreasing and concave up. So that's the shape for that function. And so now we're going to start trying to put all of that onto the same graph. I'm going to make a copy of this sketch that we got because it's going to help us. Okay, so here's the copy of the shape of the graph that we got out of the previous discussion. So this is our coordinate axis, and so out of the item C we have that the graph should have vertical asymptotes at x equals -5 and +3. Then we're told that there should be a limit of the function as x approaches infinity is -3, so this is horizontal asymptote at y equals -3. And as x approaches negative infinity, the limit of the function should be +4, and that's the horizontal asymptote for the left side of the graph. Then moving on with the rest of the items, we have the following. So for item A, we have the x-intercepts at -7, +2, and 5. So put x-intercepts -7, +2, +5. Then for the next item we have y-intercept at -7. So it's kind of a little bit off the chart downstairs, but it is -7 somewhere here. And then let's see. For the next item we have the following. Then there are values of the function. F at -3 is equal to -1, and f at 1 is -8, and f at -2 is -2. So we put all of those things in. Let's see. So f at -3 is -1, f at -2 is -2, and f at 1 is -8, so -8 is somewhere here. And talking about the rest of the things, let's see. So I guess that's all of the information that we need. So now we can start drawing the shape of the graph that follows the description. So the graph should go through this point on this side, and it should satisfy the description that we have, so it should be of this shape. So it should cling to this horizontal asymptote, go through this point, and then cling to that vertical asymptote. So if you ask me, this is probably the shape that we should be getting, so it should go like this. So it should be concave down and decreasing and going through this point. Okay. So then for the piece between -5 and -3, the graph should have this shape, and it should reach this point, and it should cling to the vertical asymptote. So that's what I got for that piece. Then between -3 and 2, it should be this shape, and should connect -3 at this point, and at x equals -2, it should go to that point. Okay, that's what we have. Then between -2 and +1, the graph should be concave up and decreasing, and it should go through the y-intercept at -7 and should arrive at this point. Okay, so we connect the dots. Then between 1 and 2, or rather between 1 and 3, the graph should be concave up and decreasing, and it should go through this x-intercept at 2. So it should more or less shoot straight up to achieve this. And on the last piece, the graph should be of this shape. It should cling to the vertical asymptote and horizontal asymptote and go through this x-intercept. So that's the only way to cling to horizontal asymptote, vertical asymptote, and to go through this point as the x-intercept. That's more or less where this graph shows up from. And again, so all of that showed up as a description of all of those conditions. So we have x-intercept, y-intercept, vertical asymptotes, horizontal asymptotes, the behavior, and the 3 key points. So let me take the original statement out. That's a version of the graph that will satisfy all of the descriptions.